Hello everyone, today we're going to be discussing the next part of our course, which is cosmology. So question probably becomes straight away, what is cosmology? And one of the important things to acknowledge straight away is cosmology isn't astronomy. It is different to a lot of the other work that we will be doing in this course. Astronomy is the study of all the objects in the universe, the stars, the planets, the dust, the clouds, the galaxies, what they are, what they do, all of that sort of stuff. Cosmology is actually the study of the universe itself. So astronomy, the stuff in the universe, cosmology, the actual universe itself. So what's the universe? Well, the universe is everything. And that's a really big statement, quite literally. Everything that we understand about the universe is everything that we understand about the universe. Without using the words universe and everything, it's really hard to explain. So perhaps one of the better ways we can think about it is trying to understand what everything actually means. And what we understand to be everything today is actually very different to what was everything back in the history of astronomy. So what we will do next is start to have a look through some of the earliest ideas of what the universe was, what this everything was, and how that's developed over time, leading towards some of the more modern cosmologies or ideas that we have today. So as these developments of technology has changed, so too have our models of the universe. So some of the earliest models that we would have had were simply trying to come up with ideas of what was day and night. What were the little white dots in the sky? So some of those explanations were kind of religious or mystical, and that's where a lot of those early cosmologies finished. So some people still work with these ideas, these mystical or spiritual ideas of what the sun and the stars and some of the celestial bodies, the constellations actually are. We're going to be working with the scientific models, not going into the realms of astrology, which we've discussed in a previous video. So one of the early documented cosmologies came from Aristotle. There's a bit of a carving of Mr. Aristotle, and he was a Greek philosopher, and he and one of his teachers, Plato, are considered to have really started the modern ideas of philosophy. So Aristotle held a belief, like many people at the time, that the Earth was at the center of the universe. All the planets and the sun revolved around the Earth. This diagram up in the top corner here sort of gives you an idea of how Aristotle viewed the universe. Earth at the center, then the moon, the other planets and the sun, all spinning around the Earth. The stars did the same. They were fixed on a circle and moved their way around the Earth. And outside was this thing, the sphere of the prime mover, which was kind of an analogy to God or some sort of overarching spirit. So this type of model with the Earth at the center is known as a geocentric model. Geo for Earth, centric, center. Ptolemy took this idea and added a bit of detail. So Ptolemy was a Roman, so an Italian who lived in Egypt. And he believed in a geocentric universe as well, just like Aristotle, but he paid attention to the observations of how the planets he could see moved in the sky. They appeared to go backwards. So if you watch the planets, they don't move in straight lines across the sky, they actually wobble and go backwards at different times. So he added some detail to Aristotle's universe and added what he called epicycles, which are little extra circles that the planets were moving in. Copernicus actually had a different idea. So Nicholas Copernicus didn't like this idea of the Earth being at the centre. He didn't feel that this actually matched the observations that were made about the way the planets and the stars moved. He came up with a different model, a model that put the sun at the centre. Very similar to what we now understand to be the correct model of the solar system. Here he had the sun at the centre, he had the planets in the same order that we understand them to be now. He did have them working in perfect circles, and the stars were fixed outside of this. So the geocentric models had the Earth at the centre. Here with the sun at the centre, we call this a heliocentric model. Helios is the old Greek word for the sun. This was not well accepted at the time. A lot of people didn't agree with this idea. Notably, the church at the time liked the geocentric models that had the humans at the centre. Humanity was at the middle of the universe. We were the very centre point, and everything revolved around us. That sounds a little bit arrogant, but that was the belief at the time. And so when Copernicus suggested this idea, he got into a lot of trouble. Galileo supported his model as well, but the two of them ended up getting into quite a lot of trouble and ended up being excommunicated at different points in time, so banned from the church and kicked out of parts of Europe because of their ideas. Eventually, though, this idea caught on. People were happy to accept the heliocentric universe. The perfect circles that Copernicus described still maintained this idea of the heavens being perfect. Then Kepler came along. Johannes Kepler was a German astronomer, and he gave us a different view of what was going on. He knew that or accepted that the Earth was not at the centre. It was the sun. And what he thought was the perfect circular motion of Copernicus's model didn't actually match his observations. He sat in his home and created very, very detailed diagrams of the motion of the planets, and he determined that they weren't moving in circles but in ellipses, oval shapes. And the detailed diagrams that he created, actually, you can see one here. This is his diagram of the motion of Mars. These diagrams described in almost perfect detail what the motion of the planets actually were, how they moved, where they moved, the shapes of their orbits, and he did it all from his house with a pen and pencil and a pretty ordinary telescope. His descriptions are still used today to work out the motion of the planets, and they're good for all but the most detailed possible descriptions that you would want. So he's something of a hero of mine. He has his detail, his work ethic, his focus in this discovery of the elliptical orbits, the oval-shaped orbits, is absolutely incredible. This one here is his description of Venus. So here we have the orbit of Mars. This is the orbit of Venus. So you can see again the incredible detail in his work. Alright, just to summarize those early models, we have geocentric models. So these had the Earth at the center, and the stars were kind of on a flat sphere outside. And so where these stars were, or just outside these stars, was considered where the gods were, or where heaven was. Often the stars were considered to be little holes in this outside, and what you could see was glints of heaven poking through. This was what the little bright lights were. So Aristotle and Ptolemy were a couple of the really major modelers of a geocentric universe. A heliocentric universe, these put the sun at the center. These have been very controversial, and they match now what we understand to be the case. Copernicus was one of the first to publicly document his ideas of a sun-centered universe, and Copernicus, through really incredibly detailed observations, described the motion of the planets as ellipses, not as perfect circles. Alright, in the next video we will start to cover off some of the more modern ideas, looking at the work of Isaac Newton and Albert Einstein, and some of the really cutting edge ideas that are starting to explain some more today. Alright, thank you, goodbye.